Assalamualaikum and hello. We continue with the second part of our chapter 1, which is the series parallel and the Kirchhoff law. In a circuit, there are series circuit and parallel circuit. As you can see here, okay, series has the same current. Okay, everything that is in series has the same current. So if you can see here, okay, this is a series. Okay, this one is in series, so the current will be the same. Okay, this one is also in series. Okay, because this is the current source, means that everything that is in here is 2 ampere. Okay, okay, this one, as I said before, this is in series. How about in parallel? Okay, parallel, in a parallel circuit, the voltage is the same. Okay, as you can see here, this one, okay, this component are parallel with this component parallel also, and this one parallel. So this, if you can see here, these are 4 parallel components. Okay, the voltage here is the same for everyone. Okay, okay, this one is parallel. Okay, if you look here, this one is parallel to each other. I give you another example. Okay, as you can see here, this one is, okay, this one is in series. Okay, series. Okay, then this one is parallel to this one. Okay, as you can see here, this is 18 volt. There is no other component, so means that the voltage from here to here is automatically 18 volt. Then if you look here, okay, this one is also parallel. Okay, this one parallel to this one, and the voltage here from here to here is 6 volt. Okay, this one also. Then this one, okay, from this point, okay, this one is parallel. Okay, this one parallel to this one, and this component and this component, okay, to this these two components are in series. So you have to make sure that you know how to use the concept of series and parallel. For series, the current is the same but the voltage is different, and for parallel, the voltage is the same and the current is different. So, okay, so we continue with Kirchhoff current law. Okay, there are two types of Kirchhoff current law. There are two types of Kirchhoff law, which is the current law and the voltage law. So we start with Kirchhoff current law, or also known as KCL. So you need to know the definition of the KCL, which is state that the algebra sum of all current entering and leaving any nodes in a circuit is equal to 0. That is the definition. Or another word is the summation of current entering the node is equals to the summation of current leaving the node. So as you can see here, okay, as you can see in here, okay, here I1 is entering, I2 is exiting, I3 is entering, I4 is entering, and I5 is exiting. So if you sum all of this current, is equal to 0. So basically it's like a piping. Okay, all, if the power current is entering, okay, current is entering, all the current that enter needs to go somewhere. Okay, so basically everything that enter needs to go out. Okay, and all the sum of current entering and exiting will become 0. So I give you an example here. Okay, the same example. How to apply it? Apply the Kirchhoff current law in a circuit. Okay, as you can see here. Okay, so you can see there are two ways to write this. Okay, the first way is to write everything in the left hand side. Okay, like this. Okay, everything is in a left hand side. So everything that enter you can assign as positive, and everything that exit you can assign as negative. So as you can see here, what is entering the node? This is the node. Okay, entering the node is I1, I4 and I3. So every I1, I4 and I3 will be positive. But okay, but I5 and I2 is leaving, so means that the sign is negative. Okay, this is one way to write to apply the Kirchhoff current law. So another way you can use this method. Okay, the second method. Okay, so everything that enter you put at the left hand side or right hand side. There's no specific way, but you can put either way. But at this the right hand side, the other side, you need to put the current that leaving the node. Okay, here. So this is two ways to apply Kirchhoff current law. Okay, now I give you another example that apply KCL with series parallel theory. Okay, as you can see here. Okay, the source is, okay, this is the source, is 120 volt voltage source, is parallel to 3 resistor. Okay, according to parallel theory, the voltage will become the same. So this is 120, this is 120 also, positive, negative, positive, negative, positive, negative. Okay, and remember the current direction. Okay, if for source, okay, for voltage source is active element, the current needs to go out of positive, so the current will goes out of positive. But for resistor, which is a passive element, the current needs to enter the positive. Okay. Okay. Now this is a I R1 I subscript I R2. This one I R3. This is how you can abbreviate the symbol for current for each resistance. Okay, how about voltage? V R1. Okay, V subscript I2 R2. Okay, and this one is V R3. Okay, this is how you write it. So voltage, as I said before, is the same as the source because it is in parallel. So 120. So you get this. Now you have to calculate what is IR1. IR1 is equals to, using Ohm's law, IR1 is equal to VR1 divided by R1. So 120, okay, 120 divided by 20. So you get 6 ohm. Okay. 6 ampere. How about IR2? The same, yo. Okay, using the Ohm's law, IR2 is equals to, okay, IR2 is equal to VR2 divided by R2. So 120 divided by 40, it is 3 ampere. How about this one? IR3 is, okay, 120 volt also. Okay, VR3 divided by 60. Okay, 60. So you get 2 ampere. So using Kirchhoff current law, this one is exiting. Okay, this one is one node. Okay, This one is only one node, and the current entering is IT. IT is equals to I1 plus I2 plus I3. So you apply Kirchhoff current law. So how to get the total current is, okay, IT is stand for total current. Usually we write like this. So IT is equals to I1 plus I2 plus I3. You get 6 plus 3 plus 2, which is 11 ampere. 11 ampere. So you get the answer. Okay, now we move on to the Kirchhoff current, Kirchhoff voltage law, or also known as KVL. Okay, so the definition you need to remember that it states that the algebraic sum of the voltage rise and the voltage drop across the loop must be equal to 0. Loops mean mesh. As I said before, you need to know the concept of loop or mesh. This one is a loop. Okay, so what it means that if you sum all the voltage here, okay, this is sum this, sum this, sum this, and sum this, and sum this, you will get 0 voltage. Okay, don't forget when you make a loop here, okay, if you meet negative, you have to put negative. If you meet positive, you have to place as positive. Okay, so that's why is this one V1 and V4, okay, meet at negatives, it put here, and this one meet at positive. Okay, so this one, okay, when you do a loop here, okay, it meet positive, positive, and this one positive. So that's why it is in this side. Okay, so all the point meet at positive, you have to put at this side, and all point at negative, you put at this side, at this right hand side. Okay, so based on this, you get the equation. And also you need to remember that when you assign a current in one direction like this, okay, you have to make sure that the current entering the passive element, as you can see here, when current move like this, so you have to make sure that it is positive. Okay, positive, positive. This is the law when it comes to positive. Okay, when it comes to passive element. But for active element, it's depend on the position of the voltage. If this position is flipped, you have to make sure that it is correct. Okay, it is according to the what with the current meet. So this one meet negative, negative, right? So this one is negative, meet negative. This one meet positive. The V4 meet positive. You have to make sure that V1 minus V4. Okay, I will show you an example later. Okay, what is important in Kirchhoff current law? Okay, this is the law. Okay, okay, you can read this. Okay, I think I already explained. Okay, I already explained all of this. So I give you another example. Okay, how to do this? Okay, if you can see here, we create a loop here. Okay, we create a loop. Okay, apply Kirchhoff voltage law. We create a loop. Okay, then remember I said when you create a loop, make sure that the current that meet the loop needs to be positive. Okay, positive and positive for passive element. Okay, for this one, okay, for this for the source, okay, for this one and this one, you need to be careful. Okay, for passive element, okay, as you can see here, V1, V2, and V3 and V4, all of it are positive. Okay, positive, 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 and positive. But for active element, which is the voltage source, you need to be careful. Okay, because this one meet at negative. Okay, it meet at negative. When you do a loop here, you meet negative, means that this is negative. Okay, if you do loop, then you do loop here, it meet positive. So you have to put positive. So active element, you need to be careful. Okay, then you have to rearrange everything. Okay, or this one is another way to put it. Okay, you put everything, every positive part, okay, every type of passive element at the one side. Can you put another one in another side? Okay, but for this case you have to be careful. Okay, and we do loop. Okay, this one is negative become positive, and this one is mid positive become negative. So you can use either way, so be careful. The answer is still the same. So I give you another example. Okay, so usually the question will give in a sentence, and you have to draw it. Okay, some of the question. Okay, find the voltage across R2 given that the source voltage is Vs 100 volt and the voltage across the R1 is 40 volt. Okay, so if you draw this, you can see that, okay, this one is Vs, this one is R1, this one is R2. Okay, now this is R1, R2, and Vs. So this one is 100 volt. Okay, so V1 is 40 volt. Okay, you have to find the V2. Okay, remember this one is volt. Okay, the direction of current, this one is positive, right? The longer bar is positive, the shorter part is negative. So the direction of current is like this. So this one become positive and negative, positive and negative, because this is a passive element. Okay, now you do loop. Okay, so if you do loop here, V R Vs equals to VR1 plus VR2. So VR1 and VR2. So if you insert the value is 100 equals to 40 plus VR2. Okay, VR2. So VR2 equals to 100 minus 40. So you get the answer. It is 60 volt. Don't forget the unit. So in the previous lecture, okay, I only discussed about the series and parallel circuit. Okay, then I discussed about the Kirchhoff law. Now we move on to the series circuit and parallel circuit, but instead of focusing on the concept of series and its voltage, and concept of parallel and its current, voltage and current. Okay, now we focus on how to change the resistance. Okay, how to simplify the resistance. Okay, this concept is called equivalent resistance. Okay, if you can see here in this slide, okay, there are 7 resistors in series. Okay, there are 7 resistors in series. Okay, now we can simplify these 7 resistors in series into only a single resistor. Okay, how to do this? Okay, basically, okay, just add all the resistors in series. So Req equals to R1 plus R2 plus and until R7. Okay, that is a simple concept. So here are here are example how this works. Okay, this is the derivation. So for the derivation, I suggest you memorize the derivation. For the derivation, we use a Kirchhoff voltage law. So as you can see here, okay, V1 equals to IR1. I is the same for all. Okay, as you can see here, I is the same because it is in series. But for voltage, it is different depending on the resistance value. So that's why V1, V2, V1, sorry, V1, V2, V3, and V only. This V is for the total here. Okay. Now we use Kirchhoff voltage law. So what we do is we make a loop here. So when we make a loop, okay, you can see here, when we make a loop, you can get, okay, negative, okay, put at this side, and then positive, negative put at the left hand side, and positive put at the right hand side. So you can see here, E equals to, okay, E equals to V1 plus V2 plus V3, because the loop here is meeting the positive part. So you get this equation. Okay. So if you insert all the value here, okay, if you insert all the value, you can say that then RT equals to R1 plus R2 plus R3. Okay. So this is how to derive the series circuit calculation for the resistance. Here I give you a simple example. Okay, this is a circuit with a series configuration. Okay. Okay, there are voltage source, 1 voltage source, and 3 resistance. So first question, find the equivalent resistance or Req of the circuit. So if you can remember, this is in series. So just sum the resistance. So here, okay, Req equals to R1 plus R2 plus R3. So you will get 3K plus 10K plus 5K, which is 18 kilo ohm. Okay. Now find the current flowing to the resistor, to the circuit. So after you combine all these three, 1, 2, 3, it will become one resistor only. So you will get like this, and instead of R1, R2, R3, you just get Req then this is 9 volt. So find the current. So this is just a simple equation, Ohm's law. So I equals to V over Req, which is 9 divided by 18k. This means around 0.5 milliampere. Okay. So find the voltage across find the voltage across 10 ohm, which is R2. So R2. How to get this? Okay, as you can remember, in series the current is the same. So when the current is the same, you just use Ohm's law. V R2 equals to 10 kilo ohm multiply by the current is 0.5 milliampere. So you get the answer is 5 volt. Now you already look at the series circuit. Now we look at the parallel circuit. Okay, as you can see here. Okay, if you look here, you can see that this one is parallel to each other. Okay, so this one is removed. This one doesn't exist. This one, it will become short circuit. So remove this. So if you see there, R1 plus R2 plus R1, R2 and R3. So the R equivalent, what is the R equivalent? So how to derive this? So the equation is basically 1 over R equivalent equals to sum of 1 over R. Okay, basically you instead of plus for series, you just plus it. But for parallel, you have to reciprocal, which is reciprocal is 1 over R. Okay, you have to reciprocal, sum it. So I give you the example next. Okay. Okay. First, I have to show. I show you the derivation. So in series, you use Kirchhoff voltage law, but in parallel circuit, you use Kirchhoff currents law. So if you see here, I equals to I1 plus I2 plus I3. This is just a Kirchhoff current law at this node. Okay. Then you know that in parallel the voltage is the same. So voltage here is the same as here. Voltage is the same as here. Voltage is the same as here. So V over RT is equal to V over RT is I1 equals to V over R1 plus V over R2 plus V over R3. So you just manipulate this and then you move around and you get this equation. So this is how the equation is derived. So a common question is how to simplify the circuit. Okay, the simplification of the circuit means that from this complex circuit, you need to convert all of this, into just a simple circuit, plus minus only one resistor. You have to convert this. Okay, this is called a simplification of circuit. Okay, the voltage is not changes. So this is a common question. Okay, if you look here, this one, this one is in parallel. So the first thing you need to know, you need to find is which one is the simplest one. Okay, this one, as you can see here, this one and this one is in series. Okay, this one is in parallel. So you can solve these two first. So this one is 50 plus 30 equal to 80 ohm. So for this one, so you use the parallel formula. So how to do this? Okay, R EQ equals to, sorry, R 60. Okay, 60 parallel. This one is symbol for parallel. 20 equals to 1 divided by 60 plus 1 divided by 20. Don't forget to invert it back. So how to use calculator? Okay, this one. Okay, if you can see here, there are x minus 1 here, this button. Okay, this button. So 60 reciprocal, okay, the x minus 1 symbol, plus 20 reciprocal equals to, then equals to, you get the answer. Then don't forget the reciprocal the answer. So your reciprocal the answer, then equals to, you get 15. So here is equals to 15 ohm. So this one become 15 ohm. Okay, this one 15 ohm, this one 80 ohm. So to avoid confusion, it's better for you to draw again. Okay, plus, minus. Okay. Okay, this one is 25, 10. Okay, this one is 15. This is 24, 20. This one is 80, 20. Okay. So now you can see that this one is parallel. Okay, this one is now in series. So how to do this? Okay, because we have to focus as the simplest one. Okay, now 20 parallel at 80 equals to 20 plus 80, and don't forget to reciprocal all. So you get, so use the calculator with the same technique. Okay, 20 plus 20, don't forget reciprocal. Okay, plus 80. Okay, don't forget reciprocal. Okay, then just equals to, you get 1 over 16, and then forget the reciprocal again, the answer. So you get 16. So now this one is 16. Okay, so if you read, then this one, or this one is 25 plus 15 equals to 40. So you simplify this again. So you have to redraw again this. So plus, minus. Okay. So this one is 10. This one is 40. Take from here. Okay. This one is 16. And this one is 24. So this one is now in series. Okay, and this one is in parallel to two of these. So if you can see here, 40 parallel with 24 plus 16. Okay, So 24 plus 16 is 40. So 40 plus 40, don't forget to close it, and this one you get 20. Okay, so you redraw it again. Okay, this one is 10, then this one is also this one is 20. So in series 10 plus 20 is equals to 30. So the Req is equal to 30 ohm. So why you have to draw again everything? Because sometimes the question asks you to find the output voltage here. Okay, you find the voltage maybe here, maybe here. So that's why you have to draw this one by one. Okay, this one is quite important. Okay, how to get the output voltage here? So first thing, look here. You have to get the I. So how to get the I? You need to calculate the R equivalent, which is you already found before. So Req equals to 30 ohm. Okay, 10 plus 20. So I, which is here, this is I. Okay, I equals to voltage 15 divided by 30, so 0.5 ampere. So because the V out, you can see here, V out is located at this side, not this side, so this side, which is the 20 ohm, equivalent. So you move here, so because this is in series, so V 20 ohm is equals to I, I is 0.5 ampere multiplied by 20, you get 10 volt. Okay, basically point here to point here is 10 volt. So now we move on to the second part. Okay, this one is 10 volt, this one is also 10 volt. Okay, this one is also 10 volt, and this one, this one is also 10 volt. So you need to go here, so you need to calculate the voltage here. How to do this? If you look here, you already done the calculation. This one is 16, right? 16 ohm. So 10 volt is from here to here. 10 volt is from here to here. So this is 24 ohm, 16 ohm. Use the same concept. So I 24, move it. 4 equals to 10 volt divided by 24 plus 16. So 1 over 3, right? Wait, 1 over 4. 10 divided by 40, 1 over 4, equals to 0.25 ampere. So the current here is 0.25. Now if you look here, this one is 0.25. So you want to find the voltage here because this one represent this point and this point represent here, because you want to find this voltage. So next is you get the voltage across 16. Voltage across 16 ohm is 0.25 ampere. Okay, the current passing through here is 0.25 multiplied by 16 ohm. Okay, 0.25 multiplied by 16, you get 4 volt. So it's 4 volt. So the voltage cross here is 4 volt. So 4 volt. This one is also 4 volt. And this one is also 4 volt. Now use the same concept here. Okay, you already get this, then you can get the next part, which is, okay, this I50 for example. Make sure that the naming is not the same as before. Okay, so I50 equals to 4 volt divided by 50 plus 30. You get 4 divided by 80. 0.05 ampere. So you get the current. Next, you want 0.05 ampere. So V out is basically just use the Ohm's law. 0.05 multiplied by 30. So you get 1.5 volt. Okay. Here is another example. Okay. So how to do first? First, like I said, find a simplest form of circuit that you can find. You can see here, this one is in parallel. This one is in series. So find the simplest form first. So then you calculate and redraw. Okay, firstly, okay, this one is 1 plus 5 equals to 6. Then this one is 6 invert plus 3. So this one, use your calculator. Okay. Okay, 6. Okay, 6 plus 3, also the same button, equals to 1 over 2. Then don't forget to reciprocal. You get 2. Equals to 2. Then you redraw this again. Okay, point here. Okay, 4. Okay. So this is 4 ohms. This is 2 ohm. This is 2 ohm also. Okay, we have calculated it. This one you have to combine it. Then this one is, this one is already combined also, 6 ohm. So what other thing you can simplify? Okay, this one is 8 ohm. So you can see that this one and this one is parallel. So 2 plus 2 equals to 4. Then this one and this one is in series, and this one will be in parallel. So 4 parallel with 6 equals to 4 inverse 1 plus 6 inverse inverse. So you get, so use the same concept with the calculator. 4 reciprocal plus 6 reciprocal, then don't forget to reciprocal the answer. Okay, here. Okay, 12 over 5. Please don't use this type of, don't use fraction. Okay, press the SD. So make sure it is in decimal. So 2.4. So here 2.4. Again, redraw. Here is Wk1. So this one is 4, 8, and this one 2.4. Now it's all in series. So 4 plus 8 plus 2.4. You get 14.4 ohms. That is the R equivalent. Okay, here also another example. Okay, how to solve this? Okay, this one is quite a little bit tricky. So if you can see here, this one is parallel because the node is the same. Okay, the start node and the end node is the same. So this one is parallel. So 20 parallel with 5 equals to 20 plus 5. So use your calculator. Same. Okay. Okay. This one is 20 reciprocal plus 5. Okay, plus 5 reciprocal again equals to, then don't forget to reciprocal the answer. Okay, get 4. So the answer is 4. Next, what you can do again? Okay, you can see here. Okay, this point and this point is parallel. Okay, because it start with the same node and end with the same node. Okay, this one and this one is not the same node, so you cannot parallel it. This one and this one, okay, you need to find the start and end with the same node. So now you can see that 18 parallel with 9. So 18 plus 9 reciprocal and reciprocal everything. So you get, okay, nine is equals to 6. So what else? So this one also cannot. So you have to redraw again. So okay, this one is also important. R equivalent is everything you need to simplify into a one resistor. But RAB is where the point A and B. Okay, you have to differentiate between R EQ not equals to RAB or any point. Okay, for example, if this one is YZ, you have to calculate this one is RYZ. So you have to be careful with this. So we redraw again. This one is 8. This one become 1 resistor. This one 1. Okay, this one become 1. Okay, 20. this one is this one 4 1, and then 2. Okay, this one is, okay, we have combined this, so it become 1, which is 6. Okay, R A B. So you can see that you have simplified it. Now find another simple component. Okay, you can see that this one and this one is in series. Okay, 4 plus 1 equals to 5. So this one become 1 and 5. Then this one and this one, you can see that it is in parallel. So 20 parallel with 5. You get 20 plus 5. Okay, 20 and 5. Okay, we already calculated. It is 4. Okay, use the same one. Okay. So again, we redraw it again. So to avoid confusion. So now it is 8. This one is 6. Okay. This one and this one. This one is 2. This one is 4. Here. Okay. As you can see here, this one and this one is in series. Okay. And then this one and this one is in parallel. So you can see that 6 parallel with 4 plus 2. So equals to 6 inverse plus 6 inverse. Okay, reciprocal, sorry. This one is 3. Okay. Okay, why? Because if you have two numbers the same, you just divide by 2. 6 divided by 2. If 3 components, 6 divided by 3. Okay, that is just way to simplify it. So again, redraw. This one is 8. Then this one is 3. So RAB equals to 8 plus 3 equals to 11. Okay, here is another example. Okay, this one is a little bit tricky. Okay. Okay, first, this one is in series. Then this one is parallel. So solve this first. So find the simple one, then solve it. Okay. 4 parallel with 1 plus 5. So 4 plus 6. So use your calculator again with the same concept. 4 inverse plus 6, 6 reciprocal. Then invert it again. Okay, if you can see here. Okay, some of the calculators show answer in fraction. Make sure you change it to decimal. So 2.4. 2.4. Oh. So again, redraw. Okay, this one equal 2.4. Okay, 1, 6. 12, 3. Okay. So if you can see here, this one, the wire jump. So, but the wire jump is here. So basically, this one you can this one, because it's the same node, you can move this outside here. Okay. Instead of just cross it, you can redraw this again to become like this. So this one and this one is now in parallel. So 12 parallel with 2.4 equals to 12 plus 2.4 reciprocal, then reciprocal again. 2. The answer is 2. Okay, the answer is 2. Okay, then you redraw again. Just to avoid confusion, better you redraw. Okay, this one 10, 3, 1, 6. Okay, this one is this value because you already combined it. So 2. So you can see that this one is in series and this one is in parallel with this. This one also is in parallel. So 3 parallel with 6 parallel with 1 plus 2 plus 1 because it's in series. So 3 plus 6 reciprocal plus 3 reciprocal. And don't forget to reciprocal all. So using your calculator, okay, okay, 3 reciprocal plus 6 reciprocal plus 3 reciprocal. So equals to, then don't forget to inverse reciprocal the answer. 6/5, then convert it to degree, decimal place. So 1.2. So the answer is 1.2 ohm. So again, redraw. Now you just get 11 and 10 plus 1.2. So 10 and 1.2 is in series. So 10 plus 1.2 equals to 11.2 ohm. Okay, for this question, you need to find the R equivalent and the power dissipate. Okay. Okay, to solve this, you of course first find the simplest form. Okay, as you can see here, this one and this one is start and end with a same node. Okay, start and end with the same node. This one is in parallel. This one also start and end with the same node. So this one is also in parallel. So first, Okay, so 12 parallel with 6 equals to 12 plus 6. So of course the same method, 12 plus 6 equals to 4 ohm. Next is this one, 20 plus 80, sorry, it is in parallel, so parallel and 80 equals to 20 plus 80 reciprocal okay inverse. So use your calculator, 20 reciprocal plus 80 reciprocal, so you get 16. Okay, of course redraw again. Okay, please redraw again, it's much more easier for you to understand. Okay, then so this one okay 60, this one is 4 from here, this one is 16 from here, this one is 15, this one is 5. Okay, now you can see that this is parallel with this series. Okay, this one is series, then parallel all of this. Okay, you can see that it is at the same node. Okay, start and end at the same node. So what to do next is 60 parallel with 4 plus 16 parallel with 15, so equals to 60 plus 20 plus 15. Okay, don't forget the reciprocal, the answer. So if you look here, okay, 60 reciprocal plus 20, okay, reciprocal plus 15 reciprocal, then equals to, okay, don't forget to reciprocal the answer. Okay, don't forget to change to decimal, 7.5. So if you calculate, after you calculate, you get 7.5 ohms. Again, redraw. Okay, plus minus 5, and this one become 1 only, so 7.5 ohm. Okay, okay, this one you have to be careful. Okay, you look here, R equivalent is considered after this. Okay, like this. Okay, so phi is not included in the R equivalent, so you have to be careful. Okay, you can lose mark because of the simple thing. So R equivalent is basically equals to 7.5 and not plus this together, because R equivalent is like this, not include this. Okay, so the second question is to calculate the power. The voltage is 40. So how to calculate the power? Either you can calculate the current, okay, depend on the question. If the question asks for the current, you have to calculate the current, then multiply with the voltage source. But if they don't want the calculation of the I out, you can just directly calculate P equals to V squared over R total. So R total is V squared is 40 squared divided by 7.5 plus 5. Okay, you get the answer. Or you can, if you want to get the I first, is also okay. I equals to V over R total. So V is 40 divided by 7.5 plus 5. So this one is 3.2. Okay, so P equals to VI. Okay, so VI is 40 multiplied by 3.2 equals to 128 watt. The unit for power is watt. If you use this method, 40 squared divided by 12.5. Also, you get directly the answer 128 watt. Okay, here are the last example. Okay, this example will consider the simplification of the resistance as well as Kirchhoff current law. So you can combine the method you already learned. Okay, this one. For this one, of course, you have to find the equivalent resistance because you want to find I1. So after you get I1, you can use Kirchhoff current law. Okay. Or another method is just R equivalent. Either way, you can get the answer. Okay. First, calculate the R equivalent. You can see that this one is in parallel and then this one is in series. So what we have to do is 8 plus 3 parallel with 6. Okay, 8 plus 3 plus 6. Okay, 8 plus, okay, using a calculator, 3 plus 6, you get 2, then 10. So you get R equivalent equals to 10. Next, you get I1. So I1 is equals to, okay, so if I redraw this again first, okay, if I redraw this again, okay, plus minus R EQ just become 1, okay, 30. This one is I1. So next is find I1. I1 equals to, so 30 volt divided by 10. So I1 is equal to 3 ampere. So you get 3 ampere. Next, you can use, okay, you find the voltage at A. So how to get the voltage at A? You know the current here is, okay, if you redraw this one by one, okay, 30, you get 8, right? This one is actually 3, sorry, 2, okay, from here 3 and 2, so you get the current is 3 ampere. So the voltage at 2, V at 2 ohms is equals to 3 multiplied by 2, 3 ampere multiplied by 2 ohms, you get 6 volt. So VA, okay, sorry, it's already put is, so just follow it, VA. So VA equals to 6 volt. So after you get 6 volt here, so you just use Ohm's law because this one is in parallel. Just I2 equals to 6 divided by 3 equals to 2 ampere. I3, okay, you can see here this is 6 ohm, okay, and the volt is 6 ohm volt divided by 6 ohm equals to 1 ampere. Okay, we have complete chapter 1 part B. So what we can conclude is that you have learned the series and parallel part of the circuit that includes the characteristic of V and I, how to identify the series and parallel circuit, and what is the voltage and current characteristic of that circuit. Then I also include the Kirchhoff current and voltage law. So this one is just a simple current. For current at node, all the summation of current is equal to 0, and for voltage you have to look at the mesh. If summation of the mesh or loop, the voltage loop is equal to 0. And lastly, the series parallel, how to combine, how to find the simplified resistance value from a series and parallel circuit. Okay, thank you.